Good morning, class. Welcome to the online classes of physics for class 10th. In the previous sessions, we were learning about the chapter light. So, we will continue the chapter today also. We have seen in the last session that what is the mirror formula, which gives the relationship between the image distance v and the object distance u and the focal length f. And that relation is said to be the mirror formula. And after that, we have seen the relation of the magnification also. What is the magnification means? That how the object size became smaller or equal to the object or became less than the size of the object. So what is the size of the image? It is formed by the spherical mirror, depends on the position of the object. So what this size remains same, or it gets bigger than the size of the object or bigger than the size of the image. So this is what the linear magnification means, that we are finding the size of the image as respect to that of the image of object or the size of the object. So here the magnification can be given as a formula, that is ratio of the height of the image that to the height of the object, that is h2 upon h1. So we have seen that h2 will be the image distance, h2 will be the image distance and h1 will be the object distance. And we know that the real image is always kept in the positive direction, and what that positive means, that is at the right side, and the negative direction is kept at the left side. But here the height is taken, so height in the upward direction will be positive and in the negative direction will be in the downward direction. So what's the side is? So if we are taking the real image, then always it is inverted image. So we are getting a inverted image, and inverted image is always in the down direction. That is where the object is kept, the image is always in the down direction. This down direction, what it means, that it is in the negative axis, that is according to the y-axis it is in the negative direction. So it will be a real image. And if the h2 is of the virtual image, then it will be positive because it is in the upward direction, because virtual images are erect in nature, that is in the same you can say that in the same axis the object is kept, we will get the image in the same axis itself. So it is in the upward direction, that is the erect image. So virtual are always the erect images, so we can say that the erect images magnification will be of the positive as well, and in the minus sign will show that the image is real and the inverted. And after that, we have seen that the ratio of the image distance to the object distance, also we can find the magnification, that is minus v by u. Okay, so h2 upon h1 can be given as a minus v by u also. So this is the relation between the height as well as the image and the object distance. And we have seen the numericals related to the this mirror formula in the last class also, but only for the concave mirrors. So we have seen that if there is a numericals question, then it is always asked that what is the nature and the size of the image. For that we will be using the mirror formula, as well as the for the size of the image and the nature of the image we will be using magnification also. See the example, that find the size and the nature of the position of an image formed when an object of size 1 cm is placed at a distance 15 cm from a concave mirror of focal length 10 cm. And we have seen, since the object is of size 1 cm, it is given as a height. Okay, so we will be not taking that height now. It is say that it is kept at a distance of 15 cm from the concave mirror, right? So it is kept at a distance means what, the object is kept at a distance, so we will be taking it as u. So u's value is given as 15 cm and it is of focal length 10 cm. Now it is a concave mirror. So concave mirror reflection or light ray reflection is always done on the bent-in surface, and in the bent-in surface always the image formation and the reflection of the rays is done in the front of the mirror, that is in the left side direction, right? And this left side direction tells us about the negative direction of the y-axis, right? So we will be taking the focal length as well as the object distance in negative itself, but in the convex mirror we will be saying that we will take in the focal length in the positive direction, because it is behind the mirror, that is it will be in the behind mirror, that is right side of the mirror, so it will be positive direction. So here we are taking the f and the u as a negative value. So for u we will be taking minus 15, and for f we will be taking it as minus 10 cm. So from here we can find the image distance also, that is negative, because it is a image formed in the concave mirror. If it is negative, if always the value of v is negative, then we can say that the image formed is due to the concave, because the image formation is negative. So we can say that is in the left side, and left side images are formed in the concave mirror itself, and we can say that the image formation is a real image. So real and the inverted images are formed, so the image distance is given as a negative. So the position of image will be 30 cm at the left side of the mirror. Similarly, we have to find the nature of the image. We had already said that it is a negative sign, so it will be real in the inverted image. Now we have to find out the size. For size, we will be using the magnification formula, that is minus v by u or by h2 by h1. So if we use the v by u or h2 by h1, we can use both for telling the size of the object. By the magnification, you can tell what is the length of the object, and by the height also you can tell what will be the height and how much it will be magnified. So we will be using m is equals to minus v by u first, and after that we will be using h2 by h1. So minus v by u, the v is a image distance, that is minus 30 centimeters we have find in the above equation. That is minus minus, it will be positive 30, and in the below it will be u, that is minus 15. So answer is minus 2. What does it mean? That it is magnified 2 times, twice it is magnified, but it will be in the down axis, that is vice negative axis. So we can think that this image is real, so the image will be formed will be inverted, so image will be in the downward direction. So this negative shows that the image is formed in the real image, and it will be in the form of inverted one. And similarly, if we have to find out the height, so we will be taking magnification h2 upon h1, and we have seen that the object is of size 1 centimeter in the question, so we will be keeping h1 as 1 centimeter and h2 as, we have to find out the h2 value, and m we already got in the first equation, that is using minus v by u. So putting this value minus 2, we will be getting this minus 2 centimeter. So we can say that the size of image will be magnified twice. So the value of object was 1 centimeter, that is height of the object was 1 centimeter. So we will be getting the image as twice, that is 2 centimeter, and this 2 centimeter long image will be formed in the real side. So we can say that below the principal axis it will be found, because it is an inverted image, it is a real and the inverted image. So here, so this is how you will be finding the nature and the size of the image. Okay, so now in this session we will be saying the rules for the obtaining images formed by the convex mirror. Now we will be saying the convex mirror. We know that the convex mirror is reflecting part is always the bulged out surface, and the bent in surface is a non-reflecting surface. Here also some rules will be there, that whenever the light ray passes parallel to the principal axis, in that also we have seen that whenever the light passes through the parallel to the principal axis, then it passes through the point focus. So here also it will be there, but see it that focus is in the right side of the mirror, that is the positive focal length will be there, because focal length is the distance between the focus and the pole. So here the pole and the focus, in 3 diagram you can see that the focus is always in the right of the mirror, that is at the behind the mirror. So we can say that the image formation will be virtual if it is there, because if we are finding the reflected ray, then we have to just extend the rays in the behind side of the mirror, that is the right side of the mirror. So this is how we can find out that the virtual images are formed, and they will be erect size, and the size will be not magnificent more. Okay, so here we can say that the convex mirror is a bulged out surface where it is reflected the light rays. If the light rays falling on the mirror is parallel to that of the principal axis, then it get reflected back, and these reflected ray will pass through the point focus after its reflection. Okay, after reflection it will pass through the focus, but this focus is not beside the mirror, it is below, or you can say the right side of the mirror or the behind the mirror. So we just have to extend the line so that it will pass through the focus. And second thing, we have read this in the concave mirror also, that whenever light passes through the center of curvature, then it reflects backs and get in the same path, it reflects backs along the same path from the center of curvature, so it is moving through the same path. And similarly we have seen the second point, that is reverse to that of the first law itself, that whenever the light parallel to the principal axis, then we get that the reflected light passes through the focus. Similarly, if the light ray is passed through the focus, and the light after reflection it will get parallel to the principal axis after the reflection. Similarly, if the light ray passes on the pole or at incident at the pole of the convex mirror, then it will reflected back with the same angle of incidence and will give a same angle of reflection. It reflects back at the same angle with respect to the principal axis. So this were the 4 laws of the convex mirror, and similar it was for the concave mirror also. The only difference will be in the formation of the images of the concave mirror. Okay, in concave we have seen that it is real and the inverted image. So here in the convex mirror we will be getting that it is a virtual and the erect image, and we have seen that the concave mirror was a converging mirror, that is we will be getting a converged image, and in the convex mirror it will be dimensed image, that is smaller than the object we will be getting, but it is behind the mirror, so it will be virtual and the erect image. Okay, so this is what the image formation, that anywhere of the point is kept, or the position of the object is anywhere between the pole and the infinity. So it anywhere it may be, but from pole to at kept any point that is at infinity, then the image formation will be behind the pole and the mirror. Okay, behind the pole and the mirror. This image you can see, this will be the image for the topic, that is formation of image by convex mirror. That is whenever the object is placed between the pole or at the infinity point, then the image formation will be done behind the pole. So this is what the object kept, and so we will getting behind the mirror. Okay, so this is what the inverted, it is not inverted, right, because it is of the same size and the same direction also, so it is a erect image. So erect all images will also be virtual image, and since it is a negative side, that is the right side, it will be taking as a negative. But here we see that the magnification is less, so we can say that in the convex mirror it is not magnified highly, and the size of the image can be said that as it is diminished. Similarly, if it is kept at the infinity, then it will find behind the mirror or at the focus point. Because it is kept at infinity, then you will get the image in the focus. Similarly, we have read in the concave mirror also. So this is the rule for the image formation in the convex mirror. So what is the use of this convex mirror? Since we are getting a diminished image, we use this convex mirror as a real view mirror in the vehicles like the bus, car, trucks, anything. The mirrors are there in the side, these are in our bikes and the cars. So this uses to convex mirror so that it can produce a erect image, that is right side up to the image of the object. So otherwise we will be getting a inverted image. So get the virtual and the erect images, we use this type of mirrors. Okay. So next thing, the numerical problems using the mirror formula, we are getting that 1 by v plus 1 by u is equals to 1 by f. Here the f will be taken as the negative or the positive. Since it is in the right side, right? It is kept at the right side. Focal length is in the right side. So we will be taking f as positive. But in the focal length in the concave mirror was negative because it is kept at the left side. Similarly, the object will be at the positive or the negative side. It will be given in the question. And the image will be positive, that is v will be taken as positive because it is a virtual and the erect image. And the same thing for the h2 upon h2, that is magnification and minus v by u. The same formula will be used. Only the sign conventions will be there for the concave and the convex mirror. Difference is there in the sign convention. So an object, see the sample problem here, that an object 5 cm high is placed at a distance 10 cm from the convex mirror of radius of curvature 30 cm. So radius of curvature is just a half, right? If we half it, then we will be getting a focal length. So from there we will be getting f's value as radius of curvature is 30. So f's focal length value will be 15 cm. Similarly, the object is 5 cm high. So here the size of the object is given, that is 5 cm high, and is kept at a distance 10 cm from the convex mirror. So this 10 cm is the object distance. So we will be taking as u as a 10 cm. So value of u will be 10 cm, but it is kept at the left side, but we will getting the image in the right side. So we can say that u's value will be negative, that is minus 10 cm, and the image formation will be of positive. So 1 by v plus 1 by u is equals to 1 by f. So on putting the values, f will be taken as positive and u will be taken as negative, and on solving we will getting the answer as also the positive because it is the image formation will be done in the right side, that is the image formation will be in the right side. So on solving, I have got here that 1 by v is equals to plus 6 cm. What does it mean? That the position of the image is found behind the convex mirror, that is the image is virtual and erect. And what is the magnification or how much the size is changed? We can find it by the m is equals to minus v by u, and again we will be using m is equals to minus h2 by h1, so that we can find out what is the size of the image will be. So from here, magnification is equals to minus v by u, we will be getting that u is negative and v is positive, and we have taken out in the equation first, that is plus 6 cm is the image distance. So v is plus 6 and u is minus 10, and minus v by u will be 6 by 10, that is 0.6 magnification is there. So we can say that the height of image is of 0.6. Okay, 0.6 magnification will be there. So on putting this m's value, we can find out the height of the image also, that is h2 upon h1, where h1 is the size of the object, height of the object, and the h2 is the height of the image. So we have to find out the height of the image. So on putting the value of m and the h1, we will be getting h2, that is 5 into 0.6, it is given as 3 cm. So the size of image is 3 cm, and in the question we have seen that it is 5 cm high object is taken, but the image is now 0.6 magnification is given, and we are getting 3 centimeters image. So it is diminished. Now it is of less size. Okay. So here we are going to learn about the lens. We have seen the spherical mirror that it is taken as that one of the part is reflecting one, the other one is a non-reflecting surface. If you take it as a straight part, then it is a plane mirror that we have learned in the first topic. And here after that we have learned that about a spherical mirror, that is a part of a hollow sphere or a hollow glass. Okay, then it is a mirror shape. Now we have seen that the anything when the light ray passes through a denser or the rarer medium, then it is said to be refraction. So in the lenses we will be seeing that refraction will take part. Okay, refraction will also take part. So here are the two types of the lenses. We can say that it will be bounded, or the transparent glass which will be bounded by the two spherical surfaces. That is, in the spherical mirror we have seen that is only one part is the spherical, that is a part of a spherical surface or a hollow sphere. But here the two surfaces will be bounded by the spherical surface. That is, if it is bulged out, then both the surfaces will be bulged out. If you are taking the bulged in surface, then both the sides will be in the form of a bulged in surface. That is, concave and the convex mirror both together will form a lens. If both the surfaces are of the convex surface, then we can say that it is convex lens. And if both the surfaces are bulged in surface or bent in surface, then it will be a concave lens. So we can say that the convex lens is thick at the center but thinner at the edges. What does it mean? Thinner at the edges means the outer surface will be bulged out surface, bulging out at the center. And similarly, concave lens will have it's thin at the middle but thicker at the edges. What does it mean? That it will bend in surface at the center. It will bend inwards, and the convex lenses will be bent outwards. Same as in the mirror, but they will have bounded by the two spherical surfaces. So here the working of refraction of the light ray will work in the lenses. Why it is? Because when they pass through the light, it will form through the two waves, right? It will be forming through the two surfaces. That is, one, it's the outside surface, that is the bulged out surface, and if it move inside, then it will go through the bent in surface. And if we take a concave lens, then it will be moving through the bent in surface, and again when it passes through the surface, then it will be bulged out surface. So we can say that the light ray is passing through the different medium. So we can say that the diffraction will be working here as based on the refraction of light rays of the sun. So what these lenses are used in? We know the lenses are used in making our goggles, spectacles, microscopes, telescopes, and many other optical instruments are used to be made with the mirrors. So that is lenses, that is concave and the convex lenses. Okay. So these lenses are used in the microscopes and the telescopes. So you may have seen in the microscope in the bio class that it is used a mirror in between, that which helps to see the objects kept in the down of the lens. And this is the type of a lens which is used, that may be concave or the convex lens. Now we will be seeing this lens will also have some parameters like we have read in the similar to that of the mirror. That is principal axis, focus, focal length, optical center, that is C, and radius of curvature R. So similarly we will be seeing all these topics in the mirror and the lenses. The center point of the lens is known as its optical center, that is O, or C is also given for the center. Similarly, the principal axis is a line that is passing through the optical center of the lens. If you are taking a center at the mirror, see this one, that is we are taking in the center in the mirror. Similarly, we are taking the center in the lens also. This, if the light ray is passing parallel to this center, then it is said to be principal axis. So optical center and principal axis. And the third one, that is principal focus. So focus is a point where all the reflected rays or lights parallel to principal axis will converge after the lens. After the lens, the point where this light rays will converge will be a focus point. So the focus is a point where all the light rays parallel to the principal axis will meet after the convergence. So we can say that in the lenses there will be two opticals, that is optical center will be single, but we will having the two poles. Okay, so there will be two principal focus, not pole, sorry. The two principal focus will be there, that is F will be in the either side of the lenses. Okay. Okay, we had it. Okay, sorry. This is convex lens and one for the concave lens. I just confused out with the image, that I have taken the same image twice. That's why. See, one is principal focus and the focal length of the convex and the concave lenses are two given here. You can see that whenever the light rays falls parallel to that of the principal axis, or principal axis is a line which passes through the optical center of the lens. So we can say that after the divergence, they get pointed to the, try to meet at a point. This point is said to be the focus. And similarly here also, after convergence, they will meet at a point which is focus, and the distance between this focus and the pole will be given as the focal length. Okay, these are some parameters for the lens. And similarly we will be seeing in the next classes also about the lenses and this and the lens formula. So this will be the last topic for your chapter light. So tomorrow maybe it will be completing also. So after that we will be starting the human and will be completing here itself. Don't think that I am lacking too much for this chapter, because only 2 chapters are going to come in the first term, and your first term most probably I think it will be happening in the November, because CBSE have released the dates as number 25 to 28 I think. So at that's too lengthy time is given, and for physics there are only 2 chapters. So if you think of a science, and there will be 6 chapters, so together we will be completing it easily. So try to complete your lab activities and the project files and the portfolios fast. Okay, so your lessons will be completed. Don't have to be hesitate about the chapters, that how you will be completing, or how whether it is completed for the term 1 or not. Okay, because human eye is a small topic, and the light is also a good topic, you can say, but it is just a similar things which you have learned in the last classes also. And 9th 8th also, I think you went through the optic chapter, that is reflection and refraction. Okay, so thank you class.